Good morning, students. In the last class, we discussed about we started with the different types of lamps, and we discussed about the uh, how the conventional lamps are there and how the evaluation is happened. So we discussed about incandescent lamp, fluorescent lamp, working principle of incandescent lamp, fluorescent lamp, how they are working, and the constructional features of the different lamps we discussed. In this session, we'll discuss about another type of lamps which are used in a illumination purpose, so that is a sodium lamp. So this is also called as a discharge lamp, sodium vapor lamps or mercury vapor lamps. There are different types are there, sodium vapor or mercury vapor lamps. They are most commonly used in the industrial purpose, so for the illumination of ads or railway ads, or illumination of the street lighting, street light or streets. So railway ads, big gordons, so there this sodium vapor lamp is used. Why? Because so in this gordons, or in case of your streets, there is no need of precise the thing. So there should, you should just want to know that there is a something object is there in front of you. So that is why, so the color of the light and other things are not matters here. Just you have to know the something is there in front of the person. So that is why the sodium vapor and mercury vapor lamps are largely used in the industrial industrial purpose, as well as to illuminate the buildings. Flood lighting you can take, or also used in the street lighting purpose or railway ads, and many more. So this gas discharge lamps that uses a sodium in an excited state to produce the light. So sodium, it consisting of a sodium in an excited state. So whenever the electric current is passed through that particular this, so sodium melts and it will emits the radiations. So that is why, so it's a excited state, it will be there. Then whenever the current is passed, the sodium gets melts and it will eliminate the radiation of light. So the efficiency is about 75 lumens per watt. The efficiency of this sodium lamp is about 75 per lumens per watt, and the average life cycle of this is around 60,000 hours. So it has a very large life cycle. So but why it is not used in the industry, household purposes? The color of the lamp is not resembles to the your daylight. That is why, so this lamps are not used in the household applications. So it has around 60 hours of life duration. Okay, so as the color is not it's a yellowish color, or sometimes yellowish color of the light it is producing. So that is why it's not suitable for the household applications. That is why it's used in the street lighting, industrial lighting, and the railway yard lighting, many more. So that's a application of the sodium vapor lamp. So next is this discharge will not starts at the low voltage. So it consisting of a sodium. Okay, so electrodes, you can see here, this is an transformer, okay, which is used to give the supply. So AC supply is given, so choke is there. Okay, and also it is a electric discharge lamp. Sorry, so this is your electric discharge lamp, so which consisting of a sodium in it. So electrodes on either side, and it is filled with the sodium. So electrodes are attached with the sodium. So this discharge will not start at the low temperature, means, so if you give the small voltage, okay, if the supply voltage is not if you apply the supply voltage of 230 volts, then electrode starts heating. Okay, the electrodes which are present on both the sides of the tube, they starts heating. So initially, so you can, I think you have observed in the street lighting purpose, so the lamps which, once you start the lamps, it will not glow completely up to 10-15 minutes. Why? Because so the temperature of that particular electrode is low initial stage. So whenever the supply, continuous supply is given, the temperature is rises, then the discharge will happens, so your light will be coming. So the leak transformer which is connected here will be producing the voltage about 400 volts. Your 230 volts is converted here. So the leaks transformer is around 400 volts it is producing. So that current will be flows through these electrodes. So electrode starts heating. So once the electrode starts heating, the temperature inside the tube is also going to increase. So if the voltage the voltage is becomes higher, so the electrode starts heats, so the temperature increases. So if the temperature increases, then your gas, the first the neon gas, which is consisting of, this discharge will start. Okay, so once the temperature increase, the discharge will starts. So first neon gas will discharge after sodium vapors and discharge continuous. So there's a neon gas is also you filled in the tube. So first neon gas will be discharged, then the sodium vapor lamps is also continuous. So the power factor is very low in this case, around 0.3. To correct this power factor, there is a capacitance is used. The capacitors of this discharge, I mean power factor of the discharge lamps are very low. To make the power factor correction, so the capacitor is used in this particular cases. Okay, that is a yellowish color, sometimes blue color of the light you will get in the sodium or mercury vapor lamp. The working principle of the mercury vapor lamp is also similar, and the construction principle of the mercury vapor lamp is also similar, but the difference is, so in case of sodium vapor lamps you will find the sodium vapors, so whereas in case of mercury vapor lamps you will find the mercury as a mercury as a mode to produce the light. Okay, so high pressure mercury vapor lamps, you can see here, high pressure mercury vapor lamps, the construction feature is almost similar to that of the sodium vapor lamp. So inner gas is used as argon, same once again. So in case of previous, there is a sodium and sodium and argon is used. So here mercury and argon is used. Okay, so inner gas which is filled inside the tube. So this is a tube. So this tube is inner gas is filled with argon. Okay, and the efficiency is around 40 lumens per watt here. In this case, the efficiency is 40 lumens per watt. So the inner tube have two main electrodes and an auxiliary electrode. So you can see, so inner tube is consisting of two main electrodes. So this two main electrodes, so first electrode and second electrode, there is a small auxiliary electrodes. So once again, so when you give the supply voltage, so capacitor is used for the power factor correction, as also these discharge lamps have a very low power factor. So to correct the power factor, the capacitor is used. So whenever the supply is given to the electrodes, so electrodes is heats up and produces the, the mercury which is present inside that tube will get ionized, it will get vaporized and produces the light. So this is the working principle of mercury vapor lamp. So both your mercury vapor lamp and the sodium vapor lamps works on the same principle. So but the difference is, in case of sodium vapor you will be having the sodium and the neon gases. So whereas in case of mercury vapor lamp you are having a mercury and argon gases. Okay, the efficiency is around 40 lumens here in this case, and it is around 70 lumens in case of the sodium vapor lamp. Sodium vapor lamps around 70 lumens per watt, it's 40 lumens per watt. The life cycle of this mercury vapor lamp is also similar to that of your sodium vapor lamp, around 60 hours, 60,000 hours. So if you're talking about the applications of this sodium and mercury vapor lamps, so to list a few, it is used in street lighting purpose. It may be in highway or state highway or national highway street lighting purpose, and it is used in the very biggest godown to illuminate it, and also it is used in the railway ads. I think you have seen the railway ads, there also it is used, and in some of the even stadiums also you will find the mercury vapor lamps or sodium vapor lamps. Or there is a flood lighting. Flood lighting is also one of the concept, so which is I think you have seen some of the aesthetic buildings are illuminated from the outside. So there is a focus light which will be focusing the building, so that is called as a flood lighting. Flood lighting is the scheme of lighting which is used to enhance the beauty of the building during the night. Okay, so there also you'll find the applications of the sodium and mercury vapor lamps. So that's about the working principle and constructional features of sodium and mercury vapor lamps. Okay, so very simple type. So initially we have started with the incandescent lamp. So incandescent lamp, before that we have a very old type of the kerosene lamps which are used. So then the evolution is happened in the field of this illumination engineering, then the incandescent lamps are comes into existence. So once again we discussed incandescent lamp working principle, and then because of some of the drawbacks, the color of the light which is consuming a more energy, and the lifespan of this lamp is very less. So because of these drawbacks, there is once again the continuous developments are happened. Then comes the your discharge lamps. So discharge lamps also, they have very positive features than the incandescent lamp. Because of those positive features, so in most of the places fluorescent lamps are, all the incandescent lamps are replaced with the fluorescent lamps. These fluorescent lamps are also designed in such a way that the existing fixtures of the incandescent lamps can be used to fix the fluorescent lamps. So this discharge lamps got a very wide publicity where they have got used in a very wide range. Okay, so once again, this also consumes some amount more than energy, not that much energy efficient. So then sodium vapor lamps, it's another applications. So then comes this mercury and sodium vapor. So because based on the applications, so these discharge lamps and all other, they are the household applications, but this sodium and mercury vapor lamps, they are used for the your industry or street lighting purpose. So in addition to this, to overcome the all the drawbacks of this incandescent lamp, fluorescent lamp, mercury vapor lamps, okay, then the LED lamps are comes into existence. So LED lamps, I think you know, LED lamps, they have a very huge lifespan compared to this incandescent, fluorescent, sodium vapor. Huge lifespan, and also consumes a less power. I mean less energy, and also it has a very long lasting. The lifespan of this LED lamps are very much high. Okay, that is why they are using nowadays in almost all the places the LEDs. All these incandescent fluorescent lamps are replacing by the LED lamps. Okay, so that is a evolution of the lamps from incandescent, I mean kerosene lamps to your LED lamps. So the artificial sources of light, if you're talking about, there are incandescent lamps. There these are all some of the list of the artificial lamps. So natural source of light is the sun. These are the artificial source. So that is incandescent lamp, fluorescent lamp, high intensity discharge lamp, that is a mercury lamps, so metal halide lamps, high pressure sodium lamps, low pressure sodium lamps. So pressure, why? Because high pressure low pressure means, so if based on the pressure difference, so you'll get the color of the mercury in a different. So high pressure mercury lamps has a pale yellow color the light, whereas the low pressure mercury vapor lamp has a some blue color light. Okay, electrode less lamps than compact arc uh, and mercury lamps. Okay, next light emitting diodes, LED, once again carbon arc lamps, gas lights, many more. Okay, these are different types of artificial sources of lights, lamps. Okay, so nowadays, because of this advantages, because of its what we can say, positive towards this one, so LED lamps are most commonly used one. So lamp efficiency is, once again, the efficiency for a light source is how well it turns the input power into the desired output. Efficiency of the lamp is defined as, or you can state as, the efficiency of light source is how well it turns input power into the desired output, which is the lumens. Desired output is the lumens. So how best your the light is transferring the your input power into desired lamp, so it is called as a efficiency. So efficiency is the actual percentage of power in which the comes out as a photons. That may also you can define the efficiency. So these are some terminologies to define the efficiency of the lamps. So this completes the different types of lamps and other things. The rest of the parts on this illumination engineering will take up in the next video. Okay, so if you got any doubts here, you can feel free to contact me. Thank you.